Tonight, there exists no destination, no problems to address, and nothing to pursue. The cosmos is expansive, serene, and enduring, and you are merely here to meander within it. High above the planet. Beyond the gentle azure shimmer of the atmosphere, past the rotating satellites and the quiet trajectories of far-off spacecraft, there lies a realm where sound does not propagate, where time feels more fluid, and where the stars gleam without hindrance. You commence there. You are suspended weightlessly in the tranquil void of space. Below you, the earth rotates slowly, enveloped in clouds akin to delicate white strokes. Yet your gaze is softly drawn away, outward, towards something far grander, the Milky Way, a colossal spiral of stars, unfurling through the dark, like a stream of radiance. From your vantage point, it manifests as a luminous strip, gentle, radiant, infinite. But as you begin to drift nearer, you discover it is not merely a strip, but a galaxy. Countless billions of stars, each with its own tail, its own serene orbit, its own cadence. And now, you are set to glide through it. You glide smoothly, without strain, carried by an unseen flow. There is no hurry here, no pressure, only movement, calm, unhurried, serene. As you near the outer fringes of the Milky Way, the stars begin to become more distinct. Initially, just a handful, dispersed like remote lights, then more and more, until they create a gentle, glowing expanse around you. You glide softly, effortlessly, swept along by an unseen flow. There's no haste in this space, no need for urgency, just movement, gentle, consistent, serene. As you draw closer to the fringes of the Milky Way, the stars come into sharper focus. Initially, only a few, scattered like far-off lanterns, then more and more, until they create a gentle, luminous expanse around you. Each star radiates its unique hue. Some are cool and azure, sparkling like frost. Others radiate a warm, golden glow, resembling distant suns at dusk. Some flicker delicately, almost as if they are inhaling. You glide past one star, then another, and sense the profound silence enveloping everything. Not an empty void, but a soothing one. A quiet that cradles everything tenderly in its embrace. Now you meander into one of the spiral arms of the galaxy. Here, stars cluster more densely, and clouds of gas and dust extend across light years, akin to cosmic mist. These clouds shimmer softly pinks, purples, and deep blues, merging like watercolor. You flow through one of these clouds. It doesn't feel burdensome. Instead, it resembles slipping through a reverie. The ambient light softens, spreads, becoming gentle and tranquil. Within this nebula, new stars are coming to life. Tiny specks of light flicker into being, gradually growing brighter. You observe one just for a fleeting moment as it takes shape. It begins as a faint glimmer, then accumulates brightness, transforming into a small, steady star. There's no noise, no explosion, only quiet creation, and somehow, it feels serene. You keep gliding. Here, time doesn't unfold as it does on Earth. Seconds elongate into minutes. Minutes melt into something softer. There's no need to quantify anything. You pass star clusters, groups that journey together, tethered by gravity. They resemble floating islands of light. As you flow through one cluster, stars surround you in every direction. It feels almost like being enveloped in a gentle snowfall. Except the flakes illuminate, and they never descend. They simply are. And so do you. In the distance, something brighter captures your attention. At the core of the Milky Way rests its center, a realm of astonishing density and enigma. You don't haste towards it. You merely allow yourself to move closer, bit by bit. As you approach, the stars multiply, drawing nearer, their light blending into a soft, radiant glow. It feels warmer here, not in temperature, but in essence, as if the galaxy itself is tenderly cradling everything together. At the very epicenter lies something you cannot see directly. A quiet, unseen force, a supermassive black hole. Yet there is no dread here. From this distance, it is not harmful, it's merely part of the equilibrium. It stabilizes the galaxy, orchestrating the motion of stars in a slow, elegant dance. You watch from a distance, feeling only calm intrigue. Now, gently, you start to drift away once more, back through the dense core, back through the spiral arms, back into the tranquil outskirts of the galaxy. The light softens again. The stars disperse, granting you space. You recognize how soothing it is to simply move aimlessly. No destination, no expectation, just drifting. Somewhere along your path, you come across a familiar type of star, a yellow one, warm, steady, serene. Orbiting it, planets trace slow, silent courses. You don't need to examine closely to understand, this is a place akin to home. Not the same one you departed, but similar. A reminder that across this vast galaxy, there are countless worlds, countless possibilities, countless serene spaces, and yet, at this moment, you don't require any of them, because you are precisely where you need to be. Asterisk, drifting, inhaling, relaxing. The Milky Way embraces you, boundless and tranquil. You start to feel lighter, more peaceful, as though the expanse of the cosmos has tenderly absorbed all stress, all clamor, all lingering reflections. Asterisk, they float away, like remote stars dimming behind you. Only this instant remains. This stillness, this gentle sway. Your breaths grow slower. Asterisk, in and out. Each inhale gentler than the last. The stars appear dimmer now, not because they have vanished, but because your mind is beginning to find rest. The galaxy keeps its slow rotation, its ceaseless dance, but you need not keep pace. You can effortlessly let go. You are secure, you are serene, you are drifting, softly, peacefully, through the gentle light of the Milky Way. Asterisk, and as the stars diminish into the backdrop. Asterisk, as the shadows grow softer. Asterisk, as your thoughts settle. Sleep starts to envelop you, gradually, naturally, effortlessly. The stars remain in their place. Asterisk, even as your thoughts soften, even as your body sinks deeper into rest. The Milky Way continues to radiate around you, unwavering and eternal. Effortlessly, the stars remain in their place. Asterisk, even as your thoughts soften, even as your body sinks deeper into rest. The Milky Way continues to radiate around you, unwavering and eternal. You persist in this gentle drift. There is no start to this voyage and no conclusion, only a tranquil continuation. In the distance, a soft glow begins to transform. Asterisk, at first, it's subtle. Just a delicate shift in the darkness, like the faintest whisper of dawn. Yet without a horizon. As you glide closer, it comes into focus. A ribbon of luminescence. It stretches across the cosmos in a slow, flowing arc, like a river made entirely of stars. This is not a solitary cluster, but a current, a long, ancient pathway of stars moving together through the galaxy. You sail beside it. Each star in the stream holds a silent history. Some are older than your sun. Some have journeyed together for billions of years, not tightly bonded, but gently. Like friends on an eternal trek, you align with their rhythm. There is a warmth in moving with them. Not ahead, not behind, just side by side. No compulsion to lead.
The colors
no
are
need
soft
to follow.
pale blues,
Asterisk,
gentle greens,
just
hints of
exist.
gold. The
As you
nebulous
progress,
edges seem
the
to
stream
shimmer,
begins to
almost
thin,
as if they're
and the
inhaling.
space surrounding
You
you
glide through
broadens
its outer
more.
layer, There is no resistance,
the darkness here
no
feels
boundary,
more profound,
just a seamless
yet not
transition
devoid.
into a
It's
space
full
filled
in a
with
different
light.
essence.
Inside,
This is one of the
everything feels
quieter
even
realms
more
of the
hushed,
galaxy, far
even
from
more
the crowded
serene.
spiral
The
arms.
glow envelops you
The
completely,
stars are fewer,
like being
yet
swathed
each
in a
glows
soft,
more
glowing
distinctly,
blanket.
like
Asterisk,
individual
and for a
notes in a
moment,
soft
you
melody.
linger, not because you
Asterisk,
must,
you glide
but
past
because
a
it
solitary
feels just
star.
right.
Each
Time
one
continues
feels
to
like
soften.
a pause,
You may
a
not
breath,
even be aware
a
of it
moment
any
of
longer,
tranquility.
not because you
Asterisk,
must,
in the
but because it
distance,
feels just
you
right.
perceive something
Time continues
extraordinary.
to soften.
Asterisk,
You may
a
not even be
gentle,
aware of it any
circular
longer.
glow. It's
The notion
faint,
of minutes,
but perfectly shaped
hours
like a
dwindles
halo
into something
suspended
much more
in the
fluid.
void.
The galaxy
As you
does not
approach,
keep time as we do.
It becomes clear,
It simply exists,
a planetary nebula,
unfolding slowly,
then another.
endlessly. Asterisk, and now. You are woven into that rhythm. Asterisk, as you depart the nebula. You feel even lighter than before. There is nothing to burden you here. No weight. No pressure. No urgency. Only movement. Only breath. Only movement. Only breath. Ahead, the Milky Way gently curves, its spiral arms extending outward like the petals of an immense cosmic flower. Asterisk, you begin to follow one of these arms again before you. The Milky Way curves gently, its spiral arms spreading out like the petals of a giant cosmic flower. You begin to follow one of these arms again. The stars increase, but not excessively. There are enough of them to create a soft, continuous glow like an illuminated path, and you follow it. Not because you need to get somewhere, but because you feel the movement is peaceful. Along the way, you pass through a larger cloud. This is a giant molecular cloud. It stretches for many light years, a vast area where new stars will one day form. Right now, some parts are dark, others are faintly glowing. Inside, you feel like you're in a dream within a dream. Shapes slowly form and disappear. Clusters of gas drift gently, illuminated by distant starlight. You glide effortlessly through it. There is no direction here, only softness. Your breathing now slows even more, in and out. Each breath deeper than the last. Each exhale leaves behind the rest of the day. Thoughts that still linger in your mind vanish like distant stars. The darkness feels deeper here, but it's not empty. It's full in a different way. This is one of the quieter corners of the galaxy far from its crowded spiral arms. There are fewer stars, but each shines more distinctly, like separate notes in a soft melody. You pass by one star, then another, each one a sense of pause. A breath, a moment's silence. In the distance, you see something strange. A soft, circular glow, faint but perfectly shaped like a halo floating in space. As you get closer, it becomes clearer. There's a planetary nebula. Long ago, a star gently shed its outer layers, forming this delicate glowing shell of gas. The central star is still there, small and bright, illuminating the surrounding cloud. As you slowly approach, the colors soften pale blue, gentle green, hints of gold. The edges of the nebula seem to tremble, as if they are breathing. You're passing through the outer layer. There's no resistance, no boundaries. Just a slow transition into a space filled with light. Once inside, everything seems quieter, even calmer. The glow completely surrounds you, as if you're wrapped in a soft, shimmering blanket. And for a moment, you pause. Not because it's necessary, but because it feels right. Time slowly melts away. You may not even notice it anymore. The concept of minutes, hours becomes more fluid. The galaxy doesn't measure time like we do. It simply exists, slowly, infinitely unfolding. And now, you are a part of that rhythm. As you leave the nebula, you feel lighter than before. There's nothing to carry here. No weight. No pressure. No rush. Just movement. Just breath. Ahead, the Milky Way curves gently, its spiral arms expanding like the petals of a vast cosmic flower. You begin to move along one of these arms. There are more stars, but not overwhelming. There are enough to create a soft, continuous glow like a path made of light, and you follow it. Not because you need to get somewhere, but because the movement feels peaceful. Along the way, you pass through a larger cloud this time, a giant molecular cloud. It stretches for light years. A vast area where new stars will one day form. Right now, some places are dark, others dimly lit. Inside, it feels like one dream within another. Shapes slowly form and disappear. Masses of gas twist and drift, illuminated by distant starlight. You glide effortlessly through it. After a while, you travel through a larger cloud, a giant molecular cloud, a vast area stretching for light years, where one day new stars will form. Right now, some parts are dark, others emit a faint glow. It feels like there's a dream within a dream. Shapes slowly appear and disappear. Gas strands twist and drift, illuminated by distant starlight. You glide easily through it. There's no direction here, only a softness. Now your breathing slows even more, in and out, each breath deeper than the last. Each exhalation releases the remnants of the day. Thoughts lingering in your mind begin to fade like dim stars. You're no longer observing the sky. You've become a part of it. You're not separate. You're not distant either. Just another silent being in this vast, gentle universe. In the distance, at the center of the Milky Way, a slow but ceaseless movement continues. Stars rotate, clouds shift. Light moves, everything moves, but nothing is in a hurry. Neither are you. You begin to feel a subtle change, not in the space around you, but in your inner world. A deeper peace, a stillness that transcends silence. Your body feels heavier now. Your mind drifts. That gentle contrast, feeling as if you are floating in the air, yet sinking into rest. The stars blur slightly. They don't disappear. They just become less distinct, like distant lights seen through closed eyes. You are drawn deeper. You sink deeper into stillness. There is nothing left to do to rest. No place left to go. The journey continues. But you no longer need to follow it. You can simply rest. The Milky Way remains endless, silent, and beautiful. But your consciousness is gently fading, like the last glimmer of twilight. Your breathing is slow. Your body is motionless. Your mind is silent. Protons will disappear one by one over trillions of years. White dwarfs, neutron stars, they will also slowly turn into radiation. The complex structure of matter will become simpler. It will decrease. It will not disappear, but it will turn into something else. What happens if protons don't decay? Then matter remains frozen. Black dwarfs could exist forever, but events like quantum tunneling can still change the structure over time. Asterisk in both cases. The direction is the same. From complexity to simplicity. From structure to non-structure. From light to darkness. Asterisk, but this is not destruction, it is transformation. Black holes will remain throughout this dissolution process. Asterisk, when stars die, black holes will remain. When matter decays, black holes will persist. When galaxies turn into ghostly structures, black holes will still remain. They are the most patient entities. A black hole is a place where even time behaves strangely. They are formed by a sufficiently large mass bending spacetime. The event horizon is the boundary beyond which the visible world cannot transmit information. Anything that falls into it never returns. Black holes grow. The massive black holes at the centers of galaxies can reach billions of solar masses. These giant hemispheres are largely formed by the merging of galaxies. When two galaxies collide, the black holes at their centers capture each other and merge to form a larger black hole. Asterisk, these mergers generate gravitational waves, causing vibrations in spacetime. These vibrations propagate through space at the speed of light. Asterisk, however, black holes are not infinite. In 1974, Stephen Hawking discovered an extraordinary fact in quantum physics. Black holes emit radiation, albeit very slowly. This radiation is called Hawking radiation. Near the event horizon, quantum fields constantly produce and annihilate virtual particle pairs. Sometimes one of these pairs falls into the black hole while the other escapes. From the outside, the black hole appears to emit a particle. In this process, the black hole loses a very small amount of energy. Asterisk, this loss is extremely slow. A black hole with the mass of the Sun would take approximately 10 to the power of 67 years to evaporate in this way. For a supermassive black hole, This time could be 10 to the power of 100 years. But given enough time, every black hole eventually disappears. In its final moments, the shrinking black hole begins to accelerate. Energy is emitted faster, and finally, a final flash occurs. A high-energy emission, a brief moment, then nothing remains. Asterisk, the event horizon disappears. The curvature of space-time flattens. The black hole no longer exists. Asterisk, this may be the universe's last dramatic event. The last light. The last movement. The last moment. After that, complete silence. What remains after black holes disappear? Particles, photons, neutrinos, and between them, an infinite, expanding, and cooling void. Interaction between these particles is extremely rare. The distance between them is so great that the probabilities are almost zero. The universe becomes a vacuum. But this vacuum is not entirely empty. Quantum mechanics states that no field can be completely empty. The vacuum is the lowest energy level of quantum fields. Virtual particles appear for a short time and then disappear. Field waves continue. These waves don't form any structure. There are no atoms, molecules, or galaxies. Just noise, meaningless, structureless, and disordered. But the vibrations continue. The universe is like an orchestra that has exhausted all its energy but hasn't completely fallen silent. The instruments are still there, but the musicians are gone. There are still vibrations, but no music. At this stage, the increase in entropy will have stopped. The universe will have reached its highest entropy level, and there will be no energy gradient. The conditions necessary for thermodynamic change have not been met. Time will continue to move forward. Space will continue to expand. But no events will occur during this process. There's a ticking sound on the clock, but the clock is working in another room, an empty room with no one in it. This is a cosmic sleep, stagnant, lightless, and silent, but a state that exists. And this state could last forever. Let's take a step back and examine the big picture. The universe is expanding. This was a major discovery. Hubble discovered this in the 1920s. Galaxies are moving away from each other, and the farther away they are, the faster they are moving away. This was momentum left over from the Big Bang. Asterisk, but something even more interesting was discovered in 1998. Asterisk, this expansion is accelerating. The universe was supposed to slow down, as expected. Gravity pulls all matter, and this pull should stop the expansion. But observations showed the exact opposite. Asterisk, we call what is proposed as the cause of this acceleration, dark energy. Asterisk, what is dark energy? We don't know. We really have no idea. We estimate that it makes up about 68% of the total energy and mass content of the universe. But we know very little about its nature. Asterisk, one possibility is the cosmological constant. This constant, which is included in Einstein's equations, states that empty space itself has an energy density. As space expands, this energy also increases, and thus, the expansion accelerates. Dark energy asterisk, the effect of dark energy is quite significant. Galaxies will move away from each other so fast that, over time, they will completely lose communication with each other. This creates a boundary called the cosmic event horizon. Light from galaxies beyond this boundary can never reach us, because those galaxies are moving away from us through space, faster than we are at that moment. This means that communication with those galaxies can never be established again. Over time, the observable universe we know will begin to shrink. Distant galaxies will first become indistinct, then disappear completely. Everything outside our local galaxy cluster will vanish from our field of observation. Only a few nearby galaxies will remain visible. Then these galaxies will also disappear. In the end, only our local galaxy cluster will remain, the converging galaxies. The Large Magellanic Cloud and the Small Magellanic Cloud, they will merge to form a single galaxy. Over time, this galaxy will also fade away, losing its stars. To describe the distant future of the universe, physicists use a mathematical concept, de Sitter space. This is a special solution to Einstein's field equations. It is the form of a universe where only vacuum energy exists, and there is no matter or radiation. The massive black holes at the centers of galaxies can reach billions of solar masses. These giant hemispheres are largely formed by the merging of galaxies. When two galaxies collide, the black holes at their centers capture each other and merge to form a larger black hole. These mergers generate gravitational waves, causing vibrations in spacetime. These vibrations propagate through space at the speed of light. But black holes aren't infinite either. In 1974, Stephen Hawking discovered an extraordinary fact in quantum physics. Black holes emit radiation, albeit very slowly. This radiation is called Hawking radiation. And then, complete silence. What remains after black holes disappear? Particles, photons, neutrinos, and between them, an infinite, expanding, and cooling void. The interaction of these particles with each other is extremely rare. The distance between them is so great that the probabilities are almost zero. The universe becomes a vacuum. But this vacuum isn't entirely empty. Quantum mechanics states that no field can be completely empty. The vacuum is the lowest energy level of quantum fields. Virtual particles appear briefly and then disappear. Field waves continue. These waves don't form any structure. There are no atoms, molecules, or galaxies. Only noise, meaningless, structureless, and disordered. However, the vibrations continue. The universe is like an orchestra that has exhausted all its energy but hasn't completely fallen silent. The instruments are still there, but the musicians are gone. There are still vibrations, but no music. At this stage, the increase in entropy will have stopped. The universe will have reached its highest level of entropy, and the energy gradient will have disappeared. The conditions necessary for thermodynamic change have not been met. Time will continue to move forward. Space will continue to expand. But during this process, no events will occur. There's a ticking sound on the clock, but the clock is working in another room, an empty room with no one else around. This is a cosmic sleep, still lightless and silent, but a state that exists. And this state could last forever. Let's take a step back and examine the big picture. The universe is expanding. This was a major discovery. Hubble discovered this in the 1920s. Galaxies are moving away from each other. And the further apart they are, the faster they move away. This was momentum left over from the Big Bang. But in 1998, something even more interesting was found. This expansion is accelerating. The universe was supposed to slow down. As expected, gravity pulls all matter, and this pull should stop the expansion. But observations showed the opposite. We call what is proposed as the cause of this acceleration dark energy. What is dark energy? We don't know. We really have no idea. We estimate that it makes up about 68% of the total energy and mass content of the universe. But we know very little about its nature. One possibility is the cosmological constant. This constant, which is included in Einstein's equations, states that empty space itself has an energy density. As space expands, this energy also increases, and thus, the expansion accelerates. The universe was supposed to slow down, as expected. Gravity pulls all matter, and this pull should stop the expansion, but observations showed the exact opposite. We call what is proposed as the cause of this acceleration dark energy. What is dark energy? We don't know. We really have no idea. We estimate that it makes up about 68% of the total energy and mass content of the universe. But we know very little about its nature. One possibility is the cosmological constant. This constant, which is included in Einstein's equations, states that empty space itself has an energy density. As space expands, this energy also increases, and thus the expansion accelerates. Dark energy the effect of dark energy is quite significant. Galaxies will move away from each other so fast that, over time, they will completely lose communication with each other. This creates a boundary called the cosmic event horizon. Light from galaxies beyond this boundary can never reach us. because those galaxies are moving away from us through space faster than we are at that moment. This means that communication with those galaxies can never be established again. Over time, the observable universe we know will begin to shrink. Distant galaxies will first become indistinct, then disappear completely. Everything outside our local galaxy cluster will vanish from our field of observation. Only a few nearby galaxies will remain visible. Then these galaxies will also disappear. In the end, only our local galaxy cluster will remain. The converging galaxies. The Large Magellanic Cloud and the Small Magellanic Cloud. They will merge to form a single galaxy. Over time, this galaxy will also fade away, losing its stars. To describe the distant future of the universe, physicists use a mathematical concept, de Sitter space. This is a special solution to Einstein's field equations. It is the form of a universe where only vacuum energy exists, and there is no matter or radiation. In de Sitter space. Expansion occurs at a constantly accelerating rate. This means that every region grows at the same rate. From every point of view, there is an event horizon through which information cannot pass. This boundary is similar to the event horizon of a black hole, but in the opposite direction. The inside of black holes is dark, while the outside is visible. In de Sitter space, each observer is as if confined within their own small visible field. There is also a temperature in de Sitter space. However, this temperature is extremely low. The event horizon emits a kind of thermal radiation. This relates to a temperature of trillions of billions of degrees above absolute zero. But it is certainly more than nothing. This temperature represents entropy. There is entropy at the cosmological event horizon. The final state of the universe has its own unique thermodynamics. This entropy is specific and limited. For a given cosmological constant, the universe can only contain a certain number of quantum states. Once this number is reached, the formation of new structures is prevented. Space continues to exist, but nothing within it changes. We can liken this to a kind of sleep. During sleep, the brain doesn't become completely silent. Low-frequency waves, light dreams, and certain stirrings of consciousness continue. But the world has become silent. There is no decision-making, no action, and no thinking. The universe will be like this in the de Sitter stage. It will continue to exist. It will continue to expand, but no meaningful activity will take place. An eternal sleep. Time is not a path of progress. We can observe changes because we think of it that way. A star explodes, a planet rotates, a person evolves. These changes are the states that fill time. But what would happen if there were no change? In the very distant future, the universe would be largely empty. Black holes would disappear, particles would decrease, and the event horizon would become inaccessible. There would no longer be any measurable change. Does time still exist? In physics, time is a part of space-time. It's like a coordinate system, an indicator we use to sequence events. But if there is no event to add value to this indicator, does it have any practical meaning? The clock ticks. But if the clock has moved to another dimension and you can't hear it, what does it matter to you whether the clock is ticking or not? The thermodynamic flow of entropy directs time. As entropy increases, time also progresses. But when entropy reaches its peak, this flow stops. It no longer moves forward because there is nowhere left to go. Mathematically, time continues to exist. It represents a symbol in equations. But whether it truly holds meaning in physics becomes unclear. Some theorists go further. They argue that if there are no longer any interactions and no observer to record the state of the universe, then time has become detached from physical reality. This is an abstract thought, but a pleasant one. Perhaps, time is a tool, a method we use to describe change. When change ends, this tool is put aside. And with this tool, the story of the universe ends. But what does it mean to end? When a story ends, it doesn't lose its existence. The book closes, but the pages are still there. One of the most frequently accepted possible ends of the universe is the big freeze or thermal death. This scenario isn't frightening. There's no explosion, no collapse, just a process of cooling, dispersion, and silence. Galaxies continue to move away from each other. Stars begin to fade. Black holes slowly disappear. Particles spread out in the expanding space. Temperature equalizes everywhere. It approaches absolute zero very closely, but never quite reaches it. Asterisk in this case. Alternative models come into play. Asterisk. The ekpyrotic model argues that the universe exists in a higher dimensional space on separate surfaces called branes. These branes collide from time to time, creating a new Big Bang. Each collision and each rebirth means a new universe with different physical constants. Asterisk in this model. Time is infinite in both directions. The first universe didn't exist, and the last universe won't. The cosmos is just a cycle. Asterisk cyclical approaches are interesting. They may need to solve the entropy problem, but that's something some theories are working on. Asterisk, perhaps the universe never disappears. Perhaps it only transforms. Asterisk, like a state of sleep. You sleep at night. You wake up in the morning. Every sleep is a little different. Every morning is also a little different. But the cycle continues. What remains when black holes melt? Asterisk, this question still awaits an answer from a physics perspective. Asterisk, one of the most fundamental principles of quantum mechanics is the conservation of information. If we know the initial state of a system precisely, we should, in principle, be able to retrieve any information coming from that system. But black holes seem to make this understanding difficult. Everything that enters the event horizon does not return. Does the information disappear? Hawking radiation appears completely random. It carries no trace of information coming from within. So, where does that information go when the black hole evaporates? There are several possibilities. Perhaps Hawking radiation actually carries information, but it is encoded in a very complex way. Understanding this requires a deeper understanding of physics. Asterisk perhaps. The information is stored on the surface of the event horizon. The holographic principle suggests this. All the information in the universe may be encoded, not in a three-dimensional volume, but on a two-dimensional surface. Asterisk, in addition, black holes may leave behind a remnant of Planck mass. At a point where the laws of physics break down, the information is preserved forever. We don't know. This is still an unanswered question, questioning whether all the information about the universe's past is truly lost. When a black hole swallows a star, is the star's identity, structure, and history of these truly erased? Perhaps the universe doesn't completely forget its own past. Perhaps our atoms carry traces of histories lived trillions of years ago in other stars, and those traces are preserved until the last particles disappear. Asterisk, that's quite a nice thought. What if our universe isn't unique? The concept of a multiverse appears in various forms in the field of physics. In apaths, quite a nice thought. What if our universe isn't unique? The concept of a multiverse appears in various forms in the field of physics. In this interpretation, every moment of choice means the universe splits in two. There are an infinite number of parallel universes. Asterisk, and space-time can vanish with it. Asterisk, this means not just the disappearance of space and time, but the dissolution of space and time itself. Asterisk, so, what remains? We don't know for sure. Perhaps mathematical laws remain. Perhaps an abstract structure. Or perhaps nothing at all. Asterisk, or perhaps it is THG of something else. During this long journey, we have never asked the question. Asterisk, where does life end? Asterisk, as far as we know, biological life requires energy and order. A high-entropy universe cannot sustain life. In trillions of years, biological life will become impossible. Asterisk, perhaps other forms of life are. I want to do a scale storm exercise for you. Let's compress the 13.8 billion-year history of the universe into a calendar year. The Big Bang on January 1st. Today is midnight on December 3, 1 Saint. In this calendar, the first stars formed at the end of January. The Milky Way galaxy began to take shape in February. Our Sun rose at the beginning of September. The Earth formed in mid-September. The First signs of life began at the beginning of October. Life arrived in mid-November. Dinosaurs appeared on December 26th and became extinct on December 30th. Homo sapiens, all of human history, appeared at 11:59 p.m. On December 31st, written history, the pyramids, ancient Greece, Rome, the Middle Ages, the Renaissance, the Industrial Revolution, to world wars, the space race, and today, all in the last 10 seconds. When you feel this scale, it becomes clear how new and rare human existence is. But consider this: in these 10 seconds, humanity learned to control fire, to write music, to try to understand other people, to look at the sky and ask questions. So much was learned in 10 seconds. And in these 10 seconds, you exist. Now, I want to talk to you about something very small, an atom. It has a nucleus, protons and neutrons. Around it are electrons, in clouds of possibilities. It's so small that there are more atoms in a glass of water than in all the water droplets on Earth. And we are made of these atoms. Each one has a history. Every proton, every neutron, has existed since the Big Bang, in different forms, in different places, in different structures, but always there. An oxygen atom that enters your lungs when you breathe. Today may have once been in a drop of ocean. Perhaps it was in the leaf of a forest tree. Perhaps a dinosaur breathed it. And before that, long before that, tit was inside a star. You are inside a star. Or, rather, the things that were inside a star are now forming you. And when these atoms came together, a miracle occurred. Consciousness, awareness, a being that can say, I exist. Physics teaches us about atoms. Chemistry teaches us about molecules. Biology teaches us about cells. Neuroscience teaches us about neurons. But none of them can explain why, when these atoms come together, something is felt. Why does pain hurt? Why does beauty seem beautiful? Why does a piece of music tighten your chest? Consciousness is science's greatest unanswered question, and you are the living example of that question. Millions of light years away. Almost complete emptiness. But the word almost matters. Because there are particles there too. Rarely, maybe 1 proton per square meter. But it's still there. Even nothingness isn't truly empty. Quantum mechanics tells us that complete emptiness is impossible. Even in the deepest vacuum, virtual particles are constantly forming and disappearing. Energy fluctuates. Space vibrates. Even in its quietest state, nothingness is not silence. That's a different and wonderful idea. Even in the most desolate corners of the universe, something is happening, and billions of light years away from those most desolate corners, on this planet, in this room, your heart is beating. The most complex, most unique form of the universe's vibration. Every star dies one day. Our sun, in about 5 billion years, when it runs out of fuel, will first swell it, will become a red giant. It will swallow Mercury and Venus, maybe Earth, too. But then it will slowly shrink. It will become a white dwarf. It no longer burns fuel, it just cools down. A slowly dying ember over billions of years. This might seem like a bad ending, but consider this. The elements currently undergoing fusion reactions within our sun will eventually scatter into space. And those elements, perhaps billions of years from now, when they gather around a new star, may form a new planet. Perhaps the conditions on that planet will also be suitable. Perhaps something will happen there too. Perhaps someone there will look up at the sky and ask, stars don't die. They transform. Matter doesn't disappear, it changes form. And this great cycle, birth, life, death, rebirth, is true not only for humans, but also for stars, galaxies, and perhaps the universe itself. Every ending carries the seed of the next beginning. Sunlight appears as a white color, but if you pass it through a prism, it turns into a hue: red, orange, yellow, green, blue, purple. All the colors are hidden there, intertwined. Light is normally a wave, and different colors mean different wavelengths. Red is a longer wavelength, purple is shorter. But these colors that our eyes can see aren't all the light. Beyond red is infrared. You can't feel it, but you do feel it as heat. The warmth from the sun comes largely from infrared radiation. Further on, there are microwaves. There are radio waves. Beyond blue is ultraviolet. That imaginary ray that sunscreen tries to block, that burns our skin. Further on are the waves we use in X-ray machines that make bones visible, and at the very end are gamma rays, the most active, most powerful radiation in the universe. All of this is the same thing, the electromagnetic spectrum, just the same type of wave, vibrating at different frequencies. Our eyes are sensitive to only a tiny fraction of this amazing spectrum. The vast majority of the universe is invisible, but it exists. Now, in this room, X-rays are passing through. Radio waves are passing through. Cosmic background microwave radiation is passing through. Infrared from the sun is passing through. All of it is filtering through you, around you, off the walls of the room, and you don't feel any of it. The universe is far more crowded than you see. Right now, every second, trillions of neutrinos are passing through your body. Stop. Read that again. Every second, trillions. Through your body, neutrinos are particles created in fusion reactions in the sun's core. They are almost weightless. They have no charge. They interact with other particles almost never. That's why they pass through everything. They pass through the earth. As if it weren't there, they pass through you. As if you weren't there. To stop a neutrino, you'd need a mass of matter denser than lead. So massive, light years thick, and yet, some of them interact so infrequently that they can be occasionally captured by giant detectors, buried underground. In the ice cube experiment, thousands of sensors are buried kilometers beneath the ice of the South Pole, and every now and then, a neutrino collides with a particle there, releasing a small burst of light. Neutrinos from the farthest reaches of the universe travel hundreds of millions of light-years to manifest themselves in the ice of the South Pole, and you, carrying that ghost, spend this night with it. Trillions of neutrinos passed through you as you listened to this story. You felt none of them. Two black holes merged, swirling around each other, billions of light-years away. It was such a violent event that it created waves in the fabric of space. Gravitational waves. Einstein calculated a century ago that these things must exist, but the technology of the time couldn't measure them, because as gravitational waves pass, space stretches and compresses slightly. How much? It's necessary to measure a shift equivalent to 1/1000th of a proton's diameter in a tube, several kilometers long. That's incredible precision. The LIGO detector achieved this, and in 2015, it detected the vibration from the merger of two black holes. The wave traveled through space for billions of years. It filtered through stars. It crossed galaxies. And finally, it reached a detector built by humans on a small planet. And there, in that subtle vibration, we heard the death dance of black holes. We think space makes no sound. But gravitational waves are, in a sense, the sound of space. And now we can hear that sound. But it was all real. Every morning when the sun rises, when the earth actually rotates, our faces are turned towards the sun again. This cycle has been going on for 4.5 billion years. Days come and go. Seasons change. Years accumulate. And within this accumulation, people are born, grow, live, and die. But the cycle continues. Dawn isn't the same every morning. A different angle of light. Different clouds. Different humidity. No sunrise is exactly the same as the previous one. But we call it morning again. Habit erases repetition. Yet every morning, the light from the sun is new. Those photons are different from those of yesterday morning. Photons that left the sun's surface 8 minutes ago. Photons that didn't exist until that moment. Every morning is the first morning, and every night, like tonight, is time to rest. The cycle progresses like this. Energy comes, is spent, rests, is renewed. You are also a part of this cycle. Sleep is a small form of rebirth. The boundary of the observable universe is approximately 46 billion light-years away. Billion. Light travels that far. But because the universe is expanding, that distance is now much greater. What lies beyond that boundary? We don't know. Perhaps there are more universes, filled with similar galaxies, similar stars. Perhaps the universe is truly boundless, and everywhere there are places like us that don't fit within those boundaries. Some theories even suggest that if the universe is truly infinite, then every possible combination must have occurred somewhere. Someone, just like you, experiencing this very moment, with your exact memories, probably exists somewhere in the universe. Is this idea disturbing or beautiful? Perhaps both. Not all the noise of the universe reaches you. Only what needs to reach you does. The warmth of the sun, the gravity of the moon, the oxygen in the air, and tonight, the words of this narrative, they are all there. They will be there while you sleep. When you wake up in the morning, the sun will have risen again. The planets will still be spinning. The universe will still be expanding, and you, with a consciousness belonging to a new day, will be here again. Good night. Sweet dreams.